Hi everyone, welcome back to another small video demonstration. In this video I'm going to show some of the visualization tools that I have come up with to visualize DeepLabCut CSV output files. So one of the things that I've been struggling with is to utilize tools like Simba, DLC Analyzer, and Bonsai to very quickly visualize my data. And in this Jupyter script, what I have done is I've tried to simplify visualization tools such as motion mapping, um, and then also the velocity and directional change visualization. So if you're looking to simplify your workflow and very easily get some of the visualizations that I have demonstrated here, please feel free to follow my GitHub page and download the Jupyter file right here and follow along with the tutorial that I have given here. And I will very briefly demonstrate how excuse me, how the Jupyter script works. Once you download the Jupyter script from my GitHub page, you can open it up in Jupyter window, such as I've done here. And from there on out, you may have to install some of the libraries using pip install. But you can find a ton of information about how to install different libraries online. Feel free to look those up. And I will just very briefly go through the parts here. In this part 2, you're going to be downloading or actually importing your data from whatever CSV file you have generated using DeepLabCut. So make sure the path here is the path correctly chosen for your CSV file. And over here, the output, you can see there are different body parts and their coordinates and the likelihood values. And in the next part, what I'm going to be doing is then creating a list of different body parts that we will then utilize in the next two next 2 and 3 actually blocks of code. So in this visualization of the average movement of two body parts, what I have tried to do is to average two body parts of whatever you desire. So in this case, I could choose nose and head, and that those body part coordinates go here. But I'm more interested in the thorax. So I'm going to leave it like that, thorax and the head. For my models for DeepLabCut, I get the best confidence intervals and the likelihood values for both head and the thorax. So because of the high likelihood of those predictions, it's best for me to utilize thorax and the head. So feel free to choose whatever works best for you. The next thing to do here is for us to give it some kind of a library or a folder to save the GIF that it's going to generate, GIF. And this will be the motion mapping of the average of the two body parts. So let me go ahead and run this and I'll show you what this will do. I'm only running this on a CSV file that has 600 frames in it. So once this gets going, so this is running, you can tell that by the kernel is busy up there. And also in my folder that I gave it, there are frames now being generated. Now don't worry about all this data here. This will all get simplified into one file once the Python script has finished executing. All right, so there it is. It takes a little while if you have a very large data set. So here's the GIF of the average of the two body part movements. Now I'm using only 600 frames for this analysis. Okay, so you get the idea of what's happening here. In the next block of code, the idea is same as the previous block, but in this case, we will be generating what are known as the optical flow diagrams. And in this case, I want to generate the vector at each of the position to demonstrate the movement velocity or the magnitude of the velocity in the direction that the mouse is moving. One thing to note here is that you can adjust the scale over here. You can make the arrows as big as you like. Let me just go ahead and make the scale small so the arrows will be really large. And again, this will get all scaled to the data set that you're working with. But just as a demonstration, I'm going to run this and show what this would look like. So kernel is busy. Let's go to our folder. So optical flow frames are being generated. Once all 600 are done, it will get compiled into a GIF and your memory will be preserved. So after the GIF is generated, wait a couple of seconds for this size to then you can start to see at each position, at each mouse's position, the arrows are changing because of the velocity magnitude change. Now, many of the large velocity changes are because of something called jitter. It's a random fluctuation happening in my data set because the likelihood values are very low for the localization of body parts. Here you can get the idea of which direction the mouse is moving in, and perhaps for some of you this would be useful, for others it may not be useful. But for my experiments, I wanted to see the directional change layered on top of the positional change for my mice. All right, so next thing to do is to, if you would like, is to generate optical flow graphs for all body parts. And this part is very quick. It gives you quick indication of which directions all of the different body parts are moving. And if you'd like, you can look up what the optical flow diagrams are and read into the code as to how these are generated. And last part of the code is a stream plot, which is again another type of visualization of direction and the magnitude of the velocity, which is the speed, and the direction that the mouse are moving in. So at each of these different positions and different frames, these are the relative directions that the mouse in my case is moving, and the magnitude, the speed is given here as a color code. So this is a very quick demonstration of this code. I hope it can help some of you, and some of you may be able to suggest different modifications for this. So feel free to leave a comment down below, and thank you for watching.